Humanity is actively mapping out its exit strategy from Earth to build a permanent settlement on the Martian frontier. The mechanical math to get there was solved decades ago. In 1990, aerospace engineer Robert Zubrin published the Mars Direct Plan, outlining how a crewed mission was possible using existing hardware for a fraction of the Apollo budget. But the rockets never launched. NASA's budget was constrained. The government shelved the initiative, and the mission lacked the necessary capital to leave the atmosphere. At an estimated cost of $10 to $30 billion, less than many annual government expenditures, reaching Mars has moved beyond engineering limits to a struggle for capital. Fast forward to the modern era, and private visionaries have stepped in to solve the physical transportation problem. Aerospace companies like SpaceX are building the vehicles required to cross the void. But there is an invisible barrier to colonization: distance. Data takes up to 24 minutes to travel from Earth to Mars. If a settler swipes a credit card, the terminal times out before an Earth-based server even receives the request. By hosting a copy of the ledger on local Martian nodes, settlers can verify and record transactions in seconds. This local synchronization bypasses the solar system's latency entirely, making a peer-to-peer system a physical requirement for any Martian economy. We are building the physical rockets to reach the planet, but we lack the societal software to survive once we land. To understand how we solve this, we have to follow two parallel tracks of history. Track 1 is the physical quest to reach the red planet. In 2002, SpaceX was founded to make humanity multiplanetary. Their development of reusable rockets collapsed launch costs by an order of magnitude. A decade later, the Mars One initiative proved a massive public demand for this hardware. Over 200,000 people applied for a one-way trip to the red planet. By the early 2010s, the physical infrastructure, affordable launch vehicles, and willing colonists was actively being secured. Track 2 is the digital history of decentralized computation. This timeline charts digital trust, starting with public key cryptography in 1974, laying the foundation for 1990s concepts like B-money and Hashcash. In 2009, Satoshi Nakamoto launched Bitcoin, proving a decentralized network could transfer massive value without a central authority. Bitcoin provided the architecture needed for a completely disconnected, interplanetary economy. In 2014, these two tracks collide. Software developer Leonard Lopin and his team launch Marscoin, officially uniting the space exploration and cryptography timelines. While Earth-based Bitcoin relies on a 10-minute block cycle, Marscoin block times are hard-coded to 123 seconds to sync with a Mars minute. The coin's halving schedule is programmed to reduce the block reward exactly every 668 sols, a full Martian year. To align the network with the mission, the founders donated 500,000 Mars to the Mars Society and absorbed the digital balances of the failed Mars One project. Marscoin functions as a permanent financial bridge, linking early space advocacy to the modern cypherpunk movement. Development on the protocol continues today. The network adopts Bitcoin Core security upgrades while preserving its Mars-specific timing constraints. This flowchart details the project's evolution into the Martian Republic, a mobile governance system built directly on the blockchain. By utilizing the public ledger, the system enables settlers to log auditable votes and permanently track property allocations. The blockchain is actively preparing the legal and democratic infrastructure of Mars before a human steps foot on the planet. Building the Martian frontier is no longer an exclusive engineering problem reserved for aerospace billionaires. Developers, node operators, and early adopters on Earth are actively compiling the socio-economic foundation of a new world right now. This effort reaches its peak the day SpaceX's Starship finally heads for Mars, carrying a copy of this completed ledger in its databanks. The physical ships are still under construction, but the software to run a multi-planetary society is already compiled, running, and waiting to launch.